Going to talk about position time graphs in general, both what they tell us as well as how we can determine the type of motion that we see based on the shape of a position time graph. So first off, a position time graph is one where we have time on the x-axis and we have position on the y-axis. This is going to tell us where we are. So where we are each second. A specific position is based on some sort of relative point. So what I like to use as a reference is like a tree. And so right here at a position of 0, that's our relative point of reference. I would draw a tree like so. If we have a positive position, then that means we are in front of the tree. So if we were to stretch out a meter tape or something from this tree outward, we would be in front of the tree if we had positive position. And if we had a negative position, which would be down here, and that means we are behind the tree. And this works specifically for horizontal motion, which is this first unit. So if, let's see, let me go ahead and extend this down here. So we've got it. If we had, say, a position time graph that looked something like this, just off of the, just talking, anything that is above that 0 line, so here, here, and here, that would be considered in front of our relative point, in front of the tree. Spots here, here, and here. Anything below that 0 line is said to be behind our point or behind the tree. So position time graphs tell us where we are each second, both how far and in what direction. Now, what if we were looking at very specific position time graphs? So not moving. Let's start with our axes. Time goes down here and position goes here, a PT graph. If we are not moving, let's say I am 1 meter, right? 1 meter away from the tree. If I don't move, I will stay 1 meter away from the tree. So in 1 second, I'm still 1 meter. In 5 seconds, I'm 1 meter. In 10 seconds, I'm 1 meter, and so on and so on. And so this turns out to be a horizontal line. Now, what if I started instead, I don't know, maybe on the tree, like at the tree, right? So then I would start here at 0. And if I'm not moving, in 1 second, I'm still at the tree. 5 seconds, 10 seconds, and so on. And so it is still a horizontal line. So the position that we're at tells us where we are, and then the horizontal line tells us that we are not moving. So the slope tells us something about how quickly we're moving. So you'll see that in just a second. Last example I'll use is, what if I was 1 meter behind the tree? And so at a -1, it is still a horizontal line. So a horizontal line means not moving. So what if I'm going forward and slow? Well, let me go ahead and draw my axes. Let's see, here's T, and then here's P. I'm going to assume I'm going to start at exactly the same position as these three others, but now I'm going to actually move forward, but slowly. So let's start with the purple. Purple starts at a height of 1 meter, right? So I am 1 meter in front of the tree. If I'm going forward, I'm going to increase in position. So I'm going to go from, say, 1 to 2 or something like that, or 1 to 1.5. Now, if I'm doing it slowly, then I'm only going to cover a little teeny bit of position, change in position, in a certain amount of time. And so if I do this, I will get a shallow slope. So slow is shallow. If I started at the origin, so let's say I was at the tree in the very beginning, and I was going slowly forward, I would still be increasing in position, but in a very shallow way, like so. And then if I started -1, so all the way down here, started at -1. If I'm moving forward, then that means I'm moving towards the tree because that is the forward direction. So it would still be a shallow slope. Now, one thing we should note about all three of these is that forward, therefore, means a positive slope. Now let's do forward fast. Let's get our axes back on here. Actually, you know what? I'm going to go ahead and draw down here as well. So here's position, and here is time. And let's start at 1 meter away from the tree. So here we are. If I am going forward but fast, fast means I cover a very large distance here in a certain amount of time. And so the more position I change, the faster I go, we get a steep line. If I start at the tree, so I'm at the origin, I'm still going to cover a very large change in position in a certain amount of time. It's still going to be very steep. And still with green, if I start 1 meter behind the tree, moving forward still means towards it. It will be very steep. So in both of these examples, they're both going forward. And what we notice is with both of them, forward has a positive slope. Positive means that the graph is increasing over time. The difference is in how quickly we're doing that. If it's a slow speed, then it will be a shallow slope. If it's a fast speed, then it will be a steep slope. And a way to remember that is imagine that this graph is actually like a hill. Which one would a ball roll down faster? It'll roll down faster on a steeper hill. So steep goes with fast, shallow goes with slow. Forward means positive. If we go back to this not moving one, this horizontal line, well, what is the slope of a horizontal line? The slope is 0. Well, if you're not moving, your speed is 0. If you're going slowly, your speed is small. And if you're going quickly, your speed is fast. And so for each of these, the slope And this is for any position time graph. The slope tells you how fast, that's the shallow versus steep, or 0. And it also tells us positive means forward, so it's how fast in a direction. How fast in a direction is called velocity. So why don't I add that to my first slide over here. So it tells us where we are each second, and the slope of the line for position time is the velocity. All right, now what if we're going backward? So instead, we're going backward. Let's go ahead and draw our axes again. So here's position and here is time, and we're going to have our exact same 3 spots. 1 meter in front of the tree, at the tree, and 1 meter behind the tree. So each one, we're still starting at the same spots. Now, if I'm going backward, then that means I'm going towards the tree. So now these PT graphs are going to slope downward because we have to approach the tree. So for the purple, remember, slow means shallow. The backward means it's going to go in a negative slope. It's going to go downward. And so purple will be like this, shallow, but going downwards towards where the tree is. For blue at the tree, it's still going to be shallow, going behind the tree since we're moving backward. And then if we start behind the tree and we go backward, then we're going to keep going further behind the tree. So backwards and slow is a negative slope that is shallow. If it's backwards and fast, fast means steep. Backward still means negative slope. So it's still going to go downward on the graph, but this time very steeply. So here we go. 1 meter in front of the tree, going backwards. So we're going to go towards the tree and on. Very steep. If we start at the tree and go backwards quickly, then we'll go behind the tree very steeply. And then, of course, if we're already behind the tree and we're going further backwards quickly, be steep going downwards. So backward is a negative slope, and forward is a positive slope. All right, the last ones to talk about. What happens if we are accelerating? Specifically, we accelerate by speeding up and accelerate by slowing down. This time I'm just going to do starting at the tree, okay? So here's P and then here's T. Remember, the slope tells us something about how fast we are going. So shallow is slow and steep is fast. Well, if we are speeding up, then that means we're going to start shallow and end steep. So let's see. Here we go. Start at the tree. We're going to start slowly, nice and shallow. And as time goes on, we're getting steeper and steeper. Do you see the shape? It's going to curve upward. So curve equals accelerate. If it gets steeper over time, it means you are speeding up because the steepness tells you something about how quickly you are going. Now, what if we are slowing down? So, position, time. This time, if we slow down, then that means we have to start going fast. We start at a faster speed than we end. That's what it means by slowing down. So we're going to start steep and we're going to end shallow. All right, so let's see. Start at the tree and we're traveling quickly. And then as time is going on, we're getting slower, which means shallower. And then there's another shape. It's going to curve in this direction. Now, if we get to this spot here, right, that's a horizontal line. So this means we are going fast, we are slowing, and if we get to horizontal, then we are stopped. Again, curve. It curves to show it is accelerating because we are changing the value of that slope over time.